Hi, my name is Dan, and this is NIVELCO Basics. In this episode, we're going to discuss thermal sensors and industrial process visualization. Let's start with thermal sensors. NIVELCO has numerous temperature measuring instruments like temperature sensors, transmitters, thermometers specifically designed to measure the temperature of gases, thermometers with reinforced flame-proof housing, and bearing thermometers. Let's go back in time, say 11 years. In 2010, one of our subsidiaries asked us to design a multipoint thermometer. In about 2 months, NIVELCO developed a market-ready device, which of course had a simpler sensor and software than the ones do these days. The device evolved into the ThermoPoint multipoint thermometer. Originally, the ThermoPoint was only designed to measure the temperature of solids. Since then, there has also been a rigid rod and a flexible tube version developed for liquids. The device was easy to develop, partly because many of its components were already used in other NIVELCO devices. The tensile weight and the flexible tube, and even the compact housing and socket might look familiar from the NIVATRAC magnetostrictive transmitter and the heavy cable probe from the NIVECONT R vibrating rod level switch. The flexible and heavy cable probes can be up to 30 meters long, and the rigid rod probe up to 3 meters long. It is a robust design with a display, a 2-wire power supply, and an analog and a hard output. In addition, there are DustEX and spark-free versions available. The 2-wire connection system of the transmitter is easy to access, and the plug-in display is an excellent tool for programming and monitoring. ThermoPoint devices can work as standalone units, where only the temperature is measured and displayed. They can also act as a part of a more extensive system, in tandem with level transmitters and visualization software. The ThermoPoint communicates with the Multicon process controller through HART. The transmitters either connect to the PC directly, or to a Multicon inserted between the PC and the transmitters. The recommended number of transmitters in a silo for solids is proportional to the silo's diameter. Check out the datasheets and user manuals for more information. The original maximum probe length of 30 meters was recently extended to 50 meters. The device received a DustEX certificate, so the electronics and the housing can both be placed in a Zone 20, which often involves the roof above the installation point as well. Previously, the transmitters could only be mounted outside the roof, designated as Zone 21, due to the former ATEX certificate. In some applications, it may be necessary to fine-tune the measured values of each thermal sensor. After modifying the ThermoPoint's firmware and the eView program, each sensor could be calibrated individually. Our upcoming development for the ThermoPoint is increasing the number of sensors on one rope from 15 to 30, thereby doubling the resolution. The ThermoPoint was first used for measuring the temperature of grains, but it found its way into the food industry, the oil and gas industry, and building services. TES tanks proved to be the most successful use of ThermoPoint transmitters. It involves measuring chilled water, where long probes, multiple detection points, and relatively high accuracy are required. A thermal energy storage tank is a huge container full of water, from which the cooled water is used for various purposes, mainly for air conditioning. The TES tank concept stores the thermal energy during the night and uses it during peak hours. Energy is stored in a liquid state, which pays off on a larger scale. It's as if the tanks were gigantic rechargeable batteries. The tank is cooled during the night, and in the daytime, the chilled water is used to cool the building in a closed circulation system. TES stations are widely used in the USA, but many other countries are starting to build similar stations, for example in the Middle East. A typical TES tank requires an array of densely placed measuring points. The sensors in the probes are placed at an offset. The distance between the sensors is 150 millimeters. Here's an example of a TES tank in the Middle East already in operation with a total of 12 thermopoint devices. These signals from the measurement points are processed and visualized either by NIVELCO's NIVISION or any Modbus query processing application that can communicate with the multicons. Let's take a look at the NIVISION process visualization software. The program is a joint development between Provicon and NIVELCO. It was written primarily for NIVELCO products, but it can be custom tailored to user needs and works with non-NIVELCO instruments as well. The tanks and instruments are configured in the program, not to be confused with remote programming, which is not possible with this software. The program displays the tank form and the measured values, and performs various calculations based on the measured and entered data. It is also possible to create trends on internal and external databases. The program will run on any modern Windows system. If an external database is used or data needs to be exported, use Microsoft Excel. A hard USB adapter is required for hard transmitters to connect directly to the computer, or in the case of multicon process controllers, an RS-485 USB modem. The instruments can connect to NIVISION either directly or indirectly through a controller, in which case NIVISION queries the controller instead of the transmitters. Use the appropriate adapter to connect the digital output of the instruments directly to the program. This arrangement is recommended for small systems, as only a few devices can be connected to a hard loop. The second method is recommended for larger systems, where there are many transmitters, possibly several controllers such as NIVELCO's multicon, and the controllers are connected to NIVISION using an RS-485 USB adapter. I'd like to stop here for a moment to say a few words about the multicon. It is a controller that receives 1 to 15 hard-compatible transmitters as input. It can also power these transmitters, and NIVELCO transmitters can even be programmed remotely from the instrument panel. With the buttons and the large display, it is easy to program the transmitters and the controller itself. The multicon has relay and current loop outputs. The unit can be programmed to perform basic calculations and process control tasks. The available options include an internal memory data acquisition function, a USB port, expandability with external modules, and an RS-485 output. NIVISION can handle multiple instruments and communication protocols at the same time. Here are a few completed NIVISION projects, mostly involving thermopoint thermometers, supplemented with level measurement. This flowchart was made by one of our clients. The process visualization project involved fuel measurement with an accuracy of a few tens of liters. This one is a functional project with tank displays and data entry options. Thank you for watching. The presentation was made by Alpar Kovac, and we hope it will help you find the right device.